Hi guys, my name is Eric Siow. Today I would like to introduce the working principle of relays and its drawbacks leading to the usage of PLC in industries.
The working principle of the relay isn't hard to understand. Here is an instance of a common relay. First of all, here is several basic components for the intersection of the relay. This is the iron core worn by the control coil at the contacts, which is open circuit right now. And this is the movable iron armature. Besides, this part is usually called control switch. We'll explain its function later. Now, combine the relay with other components, power supplies, and the load terminal. When the coil current is switched off, there is a force pulls the movable armature back to its original position. This force is mainly provided by the spring gravity above them. As shown that the power source are given to the electromagnet through a control switch and through the contact to the load. Then it can activate the electromagnet and hence generating a magnetic field to attract a contact. The magnetic force is usually twice the force that will pull the movable armature back to its original position. As shown in here, the circuit will be shorted and the light bulb will be lighted up.
The relay function is not mechanical like conventional relay systems and components, and that the internal relay systems of a PLC are solid state. In a relay, conventional mechanical relays actually wear out much quicker. When a mechanical relay opens and closes, the arcing will occur and eventually destroy contact, but this does not happen in the solid state type relays. Another advantage of a PLC system is programming flexibility and easy expandability. For instance, if you just want to add a timer to make a motor turn on after 5 seconds, then they just need to add it to the program in PLC. For a relay system, users would have to add an entirely new physical component and all of the proper wiring to make the timer works for a specific motor, so it costs more. Another great point of PLC has over a conventional relay network is the ease of troubleshooting. In a relay system, there will be more wires, relays, and other components that are not needed in a PLC. You can only imagine how much easier it is to troubleshoot the multiply output PLC system compared to the relay system with 4 times amount of wires. Most of the physical relays, timers, counters, and controllers from the relay logic system are all contained in the PLC itself. The size of a relay logic cabinet can be 3 times of a cabinet that contains the PLC. Relays require constant maintenance, cost more, and couldn't be easily reconfigured. Incidentally, keeping a similarity of the old system was vital, therefore, ladder logic was coming out as the first PLC programming language.
Hi, my name is Mastura Binti Zulkeply, and today I would like to introduce about ladder logic diagram and how to read them. Ladder logic diagram is one of the most common used programming languages in Programmable Logic Controller, or better known as PLCs. Before the invention of PLCs, relays were used mainly in manufacturing plants. Since relays are hardwired, costly, and not easy to configure, thus resulting it to be impractical, PLCs came into the picture and has been used widely in industry environments until now. Unlike relays, ladder logic is easy to learn and also easy to troubleshoot. And to troubleshoot, it is crucial to trace the logic in order to figure out why the output is energized or what's preventing it from turning on. This ladder shape structure has 2 vertical lines called rails and horizontal lines called rungs. The left vertical rail is the power supply and the right vertical rail is the neutral conductor. Logic instructions on the left side are called input, whereby on the right side are called output. In order for one to understand the ladder logic diagram, documentation is necessary. Documentation is the process of naming all the inputs and outputs as well as numbering all the wires, and this is for the purpose of easy referencing. In this video, I would like to introduce these 4 well-known instructions in PLC. Firstly, examine if closed, XIC. If the boolean assigned to the XIC is true, the current will go through, and if it's false, it will not. Secondly, examine if open, XIO. XIO is the exact opposite of the XIC. Hence, if the boolean assigned to XIO is false, current will go through, and if it is true, it will not. Thirdly, output energize, OTE. If input instruction is 1, then output instruction is high. If 0, then the output instruction is false. And the last, timer on, TON. A condition created by user will start an internal timer and execute the action based on what the user has programmed. Timer will then start counting and the input is energized. In order to learn ladder logic diagram, to identify the flow of current is crucial in terms of where is the path that the current will take. Firstly, it will fall in a way that when the power is on, current starts from left to right rail and it will attempt to flow through one round at a time. When it encounters an input condition, it will identify if the result is true or false. If the condition is true, the current will execute the instruction. If it is false, the current will go to the next round. And here is an easy example. The following is the steps on how to read ladder logic diagram for a situation when XIO instruction is included. Recall back that XIO instruction only let current to pass through if the boolean assigned to it is false. First of all, given condition 1 and condition 2 on round 1 and both are in series, and condition 3 on round 2, which is in parallel with condition 1 and condition 2, the output is energized 1. Then, when the power is turned on, the current will start flowing from the left part of the round. If XIO instruction is tied to these conditions, if the condition 1 is false and condition 2 is true, current will pass through condition 1 but stop at condition 2. And that the current will go back to the first branch in order to find another path. Remember, the goal is to reach energized 1 output. So, since condition 3 is false, then it will pass through it and finally reaches energized 1 and thus set it to high.
Hi, I'm Yee Hong. Today I will be giving my comment on the issue that were mentioned in this YouTube video. Actually, there are plenty of industry factories have their PLC connect to the internet in order to remote real-time data collection, monitoring, and increase the maintenance efficiency. Individuals who use PLC usually work in respect of factory, power station, transport, and oil and gas. Now I will be introducing some useful precautions and prevention for PLC. First of all, manufacturer can reduce the risk from getting cyber attack by limiting the person who can access to the device that are connected to the PLC. Allow the IT manager to control each worker access and track the action. As such, each person that required access must be given a personal account with different level of access depending on their needs. Just like PC at home, there are software that will protect PLC to a certain extent, installing antivirus software to protect the PLC. However, hackers constantly develop techniques to introduce malware to computers or PLC once they realize the previous methods are not valid anymore. Routinely update the antivirus software is recommended to minimize the risk of being sabotaged. Moreover, passwords are perhaps the most common authentication technique. Therefore, never share a password with your friends and never use default password as your password. Passwords should be high in complexity, including symbol, alphabet, number, or change the password on regular basis. In addition, all of the access points to critical system must be limited only to those necessary for system function in order to minimize the total number of access points available to attacker. For example, hardware communication ports like USB serial ports. The number input and data generated by digital control system is a valuable commodity. Thus, routine backup of critical data is an essential part of any cyber security program. Moreover, to thwart the so-called active attacks, where the attackers insert or modify data in digital system to achieve malicious end, is to engineer the system in such a way that all the communicating data is read-only and therefore cannot be written or edited by anyone.
Last but not least, knowing the basic knowledge of PLC will effectively give users a more computer control for the internet connected devices, and this will allow a more effective operation of industrial working and change the human society. This is the end of the video. Hope you enjoyed this video and thanks for watching.